The circumcenter of a triangle. And the circumcenter of a triangle, let's say we have a rough sketch here, is where we get the perpendicular bisectors. So that's lines that cross at the midpoint and are perpendicular to each of the other sides of the triangle. The triangle's disappearing. And we're looking to where they all cross. So maybe in this case they all cross right there. That would be called the circumcenter. So we have 3 coordinates, and we'll quickly take a look at what they look like on a graph. I've quickly graphed them out here. So here are 3 coordinates, 0, 0, 2, 8, and 5, negative 4. Don't worry about these purple lines. It's just to make it look like a triangle. Those were the equations we had to use. So for perpendicular bisectors, since all 3 of them will cross at the exact same spot, what that means is we really only have to focus on 2 of them. So I'm going to focus to start with side AB. So side AB, we need to find first the midpoint. So let's go midpoint, and I want to change my pen. There we go. Find the midpoint. So find midpoint, we're going to add our 2 x values. Okay, so our x midpoint is going to be equal to 2 plus 5 divided by 2. And our y midpoint is going to be equal to negative 4 plus 8 divided by, let's done this page, 2. So our x midpoint means 7 over 2, and our y midpoint ends up being 4 over 2. We'll leave that one as a fraction, and we know this one will be 2. So our first midpoint is 7 and 2. 7 over 2 and 2. So we'll actually go ahead and plug that into our graph here. And that's really 3.5, but we'll write it as a fraction. And 2. And if we take a look, that's the midpoint between A and B. So that works out great. We know we've done that part properly. The next one we could look at is maybe B and C. And I'm just going to change the thickness of this line. There we go. Okay, so B and C. Same idea. The x midpoint will be equal to, we'll add the 2 values together. So 5 plus 0 divided by 2, which is going to equal 5 over 2. And the y midpoint is going to equal negative 4 plus 0 over 2, which is going to be negative 4 over 2, which equals 2. So our other midpoint ends up being 5 over 2, okay, which is 2.5. And, sorry, that should be negative 2. So let's do the same thing and plug that in to our graph also. So that gives us 5 over 2. And negative 2. And again, we've got our 2 midpoints. So this is great. Those are going to be really important to us. The next things we have to do is find out the slopes of both of these. So I'll find out the slope of AB right below. And the reason we need the slope is because in order to find a perpendicular bisector, we need to have a perpendicular slope. So we're going to focus on AB again. That's 2, 8, 5, negative 4. I'm just going to write them again. 2, 8, and 5, negative 4. So in order to find the slope, we're going to subtract our y values. So a lot of times slope is denoted by the letter m. So we say m is equal to negative 4, subtract 8, over 5, subtract 2. Slope ends up being negative 12 over 3, which is equal to negative 4. Okay, that's good. But we need a slope that is perpendicular to that. So if we're thinking of that as being a fraction, negative 4 over 1, a perpendicular slope of that would be the negative reciprocal. So it's going to be positive, and it's actually going to be 1 over 4. For the slope of our perpendicular bisector will then be y is equal to positive 1 over 4, x plus b. And we still got to find the entire equation of that line. And to find the equation of that line, we need a point that it crosses through. Well, it actually crosses through the midpoint over here, right? We know that our slope is going to be, what did we say? It was 1 over 4. So we'll say 1 over 4x. And that looks like it'd be it, but it's not crossing that point yet. So we need it to cross that point, 3.5 and 2. And I'm going to use the fractions to solve it. We're going to plug in our midpoint, which was 7 over 2 and 2. So that is the x and the y value. So we're going to plug those in for the x and the y value. And that means 2 is equal to 1/4. And the reason I like using fractions, for instance, when we come to multiply here, instead of having to multiply a decimal, I know my fraction rules well enough, I can just multiply across. So I end up with 7 over 8 plus b. When I bring that to the other side, we get 2 subtract 7 over 8 is equal to b. So I need, in order to add or subtract fractions, we need the denominators to be the same. So this is going to be 16 over 8 subtract 7 over 8, which will equal our b value. So our b in this case would be 9 over 8. Great, so when we go to plug that in for our equation here, slope was 1 over 4x, and our b value would be 9 over 8. And you can put that as a decimal. Again, I'm going to use fractions just because I find them simple to work with. So there we go, perfect. It crosses, and it is perpendicular to our one side of the triangle. We have to repeat this same process with our other line, which was, let's scroll all the way to the top, BC. And again, we'll use red. So for BC, I'm going to find the slope. I'm going to write those points out again. The slope of B, coordinate B, oops, went the wrong way, sorry, 5, negative 4. 4, and coordinate C was 0, 0. So we find the slope, again, M, and we'll go negative 4, subtract 0, divided by 5, subtract 0. And our slope is going to be negative 4 over 5. And we need to find the negative reciprocal to 4 over 5, so to be perpendicular to that. To be a negative, that will end up being positive, and it's going to be 5 over 4. So our line is going to read y is equal to 5 over 4x. And we just got to figure out what the b is. So I'll type that in again. You know we're going to have a line that is 5 by 4x. That looks like it could be perpendicular to this line here. I'm going to change its color to green. Okay, so we know that our perpendicular bisectors are green. We still got to solve for the b. And again, that's got to go through that midpoint. The midpoint was 5 over 2, negative 2. So I'm going to try to squeeze it in here. 5 over 2, negative 2. That's our x and our y value. So we're going to plug those in for the x and the y here because we know they cross those coordinates. So the y was negative 2 is equal to 5 over 4 times 5 over 2. Again, that's why fractions are helpful here. We just multiply our fraction rules, which is 25 over 8. 2 plus b. When I bring it over, we get negative 2 minus 25 over 8 is equal to b. This one will be negative 16 over 8. When we change it to a fraction, that too. Remember, it's technically over 1. We multiply the top and the bottom by 8. That's how we get that. Negative 25 over 8 is equal to b. Values together, we're going to get negative 41 over 8. Oh, I really changed the thickness of that line. Let's go up just a little. It's equal to b. And change it one more time. Apologize for playing around with that in between. So our equation will read y is equal to, again, our slope was 5 over 4, was a better thickness, minus 41 over 8. Again, you could change that into some fraction, or sorry, decimal, but I think that should work out pretty well for our purposes. And there we go. So the last step we have to do is find where these two lines intersect. And as you notice, it's not even inside the triangle. We can tell by looking at our graph here because the program does it. We know our point. So what I'm still going to do is I want to prove it using substitution or elimination. So we'll go back and we look at these two lines here. And essentially we have to find where they intersect each other. So since this one's already set equal to y and this one's set equal to y, we can already set them equal to each other. Think of it like we're taking this value and we're plugging it in for the y value over here. So I guess we'll do this part in blue. We'll get 5 over 4x minus 41 over 8 is equal to 1/4 x plus 9 over 8. So at first we're going to solve our x value. We use substitution. I want both my x values on this side, so we get 5 over 4x minus 1 over 4x is equal to 9 over 8. And then when I bring 41 over, it becomes plus 41 over 8. Okay. We subtract, we get 4 over 4, which is essentially 1x. So that works out really good. We're right down to x. When we add these values, we get 50 over 8. And because our program shows things in decimals, we're going to figure out what that is by using our calculator here. 50 divided by 8, 6.25. So when we take a look over here, 6.25 is definitely the x value. And then to find the y value, we just take either of the equations. I'll take the first one, and we plug in the x value we found for it to isolate for y. So our equation originally read y is equal to 1 over 4x. 1 over 4x plus 9 over 8. There you go. Plus 9 over 8. We're going to take this value and we're going to plug it into the x value to find out what our y is. So y is equal to 1 over 4 times 50 over 8 plus 9 over 8. So a little more math involved here. Y is equal to 50 over 32. And I'm going to quickly change this one. In order to make this denominator 32, we need to multiply both the top and the bottom by 4. So we put plus 36 over 32. So our y value is equal to 86 over 32. So some fraction, and again, let's use our calculator to figure out what the decimal is, because in our program it uses those values. So we have 86 divided by 32 is equal to 2.6875, 2.68, and they rounded. So there we go, perfect. It worked out exactly the way we needed it to. And that is how you find the circumcenter of a triangle.